Hi guys, in this tutorial I'm going to solve the question number 7, June 21. A slide of playground makes an angle 30 degrees with the horizontal line and its length is 2.5. The horizontal section in the same vertical plane. The child has mass 35 kilogram, it's a given. Modeled as a particle P started from rest at the top of the slide in straight down sloping section, then continuous along horizontal section until comes to rest. Until comes to rest means the final velocity is 0. There is no instantaneous change in speed when the child goes from the sloping. Here, the end or the final velocity of the inclined, use it as initial when the particle or the child move horizontally. The child experiences a resistance force on horizontal section of the slide and the work done against resistance. The work done against resistance in this part is equal to 250 joule per meter. It's given that the sloping section of the slide is smooth. The slide is smooth. Find the speed of the child when she reached to the bottom. How to solve this type of questions? We can use forces, second law, or we can use the work done. First, if we use forces, when the particle slide down, so mg sine theta, you have to show it, this part, mg sine theta. And it's written in this part smooth, there is no friction force. So all the forces in direction of motion, it's mg sine theta minus all the forces in opposite direction, but there is no force, is equal to ma. So the particle move with acceleration, which is g sine theta. So a is equal g10 times sine 30. So the answer will be 5 meters per second squared. And we have initial velocity started from rest. Acceleration found it's 5, and the displacement of the plane distance is 2.5. So you can find the velocity v squared is equal u squared plus 2as. So v squared is equal to initial velocity 0, 2 times 5 times 2.5, then by taking the square root. So the answer will be 2 times 10 will be 10, times 25 will be 25. So the answer will be 5 meters per second. And also I will again solve this part by using work done. It's smooth. So the change in kinetic energy is equal to change in potential energy. This particle starts from rest, so the change in kinetic energy, it's only half mv squared. Half mv squared is equal to mgh. So we can remove m. So half of v squared equal g10, and h, which is the perpendicular height, you can calculate it, which is 2.5 multiplied by sine 30. 2.5 multiplied by sine 30. From this equation, you can find the value of v. You will get the same answer, which is 5. It's a 10 multiplied by 2.5 multiplied by sine 30 is equal to times 2 by taking the square root. So the answer will be 5. This is part A. Second part, he asks, find the distance that the child travels along the horizontal section of the slide before comes to rest. Now, we'll deal with this part. Also, we can use the work done, or we can use forces, both correct. I will use the work done first. Now it's rough, so because it's rough, the net work is equal to change in mechanical energy. The network means the work done by driving or the work done by the external force and the direction of motion minus the work done against the direction of motion is equal to change in mechanical energy. So the change in kinetic energy and the change in potential energy in general. I'd like to write this equation each time. Work done by driving or work done by a force in direction of motion there is, minus the work done against resistance. It's a given, but it's a given per meter. So will be 250 times the distance applied. A change in kinetic energy, final minus initial. Final, which is half mv squared minus half mu squared. And change in potential energy, there is no change in potential energy. And the final velocity, it's written 0, so will be 0. So now negative 250 multiplied by d is equal negative half times mass, which is 35, times v, which is 3, is initial velocity, which you found before, which is 5. So will be 5 squared. By solving this equation, you can find the distance. It's 0.5 times 35 times 25, then divided by 250. So the final answer is UD is 1.75 meter. I'll explain this part again, but you can use forces. How? All the forces in direction of motion is 0. Minus all the forces in opposite direction, which resistance is 250, is equal to MA. Mass is given 35, so you can find the deceleration. After finding the deceleration, we already have initial velocity, which is 5, final velocity, which is 0, and the acceleration. Acceleration is negative 250 divided by 35. So the answer will be negative 7.14. So now we have initial velocity, final velocity, acceleration. So you can apply v squared equals u squared plus 2as. You will get the same answer also. Part B, it's given that instead that the sloping line is smooth, now it's rough. And the child come to rest on the slide 1.05 meter after she reached the horizontal section. This is the inclined plane. This is the horizontal one. Now we'll show the information which is given. Now V is equal to 0 when it is moving 1.05 on the horizontal plane. And we start from this part from rest. Ask to get the coefficient of friction. First, which part we already have enough information? Look at the horizontal line. The horizontal line from the previous part, we already calculate the acceleration. If we repeat this part again, I will solve it by using the forces, then we'll repeat it again by using the change in mechanical energy. So we have resistance in this part or friction in this part is equal to 250. And this is the resistance or the friction force. If we write equation of motion of inertia of this particle when it's moving to the right side and all the forces in direction of motion will be 0 minus opposite direction, which is 250, is equal to MA. The mass will be 35 and acceleration, and we calculate the acceleration before, which is negative 7.14. Negative 7.14. So the acceleration in this part is negative 7.14. You can use it to get the initial velocity. So the initial velocity when the particle starts Initial velocity, we don't have time, so v squared is equal to u squared plus 2as. The final velocity is 0, initial velocity plus 2, acceleration negative 7.14 times 1.05. You can solve this equation to get the value of u. 2 times 7.14 times 1.05 is equal to square root for the answer will be u is 3.87. This is the initial velocity. Now look at the inclined plane. Start again. First step, initial velocity 0, but now the final velocity found is v now is 3.87. The particle slide under what? mg sine theta. So by using the forces again, all the forces in direction of motion is mg sine theta minus all the forces in opposite direction is equal to ma. And normal reaction is equal to mg cosine theta. If I show the resolving forces, this is mg sine theta, inclined plane, which is 30. And this is mg cosine theta, and normal reaction and opposite direction is friction force. R is equal to mg cosine theta. Frictional force is equal to mu r. You can calculate the value of friction force from the first equation. Mass is 35, g is 10, sine 30, minus frictional force is equal mass 35, and the acceleration is equal to, we didn't find, so we'll find it again. Inclined plane v squared equals u squared plus 2as. The final velocity found 3.87 all to the power of 2, initial velocity 0 plus 2 times acceleration times displacement, the length of the inclined plane, which is 2.5, correct? Then solve the equation to find the acceleration on the inclined plane. This acceleration is 3.87 squared divided by 2 times 2.5. So the answer will be 2.99. So I will write here 2.99. From this equation, you can find the value of the frictional force. Frictional force will be 35 times 10 times sine 30 minus 35 times 2.99. So the frictional force is 70.35. From the second equation, you can find the normal reaction. It's a 35 times 10 times cosine 30. So the normal reaction is 350 times cosine 30 is equal to 303. 303.1. Now to get mu, which is frictional force over normal reaction. Friction force 70.35 divided by 303.1. 70.35 divided by 303.1. So the final answer is mu is 0.232. This is the final answer for the value of mu. This part, again, you can solve it by using the work done. So when you apply it in inclined plane, all the force, the network is equal to change in mechanical energy. So the work done by driving force minus work done against resistance is equal to change in kinetic energy and the change in potential energy. So you have to get the work done by driving. There is no work done. So the work done against the friction force will be minus frictional force times distance, which is 2.5, is equal to change in mechanical energy. It's half mv squared minus half mu squared, This part will be gain, so don't forget to write it positive. And there is a loss in kinetic energy, loss because it will be mg, mgh. You can find m and g and h, the vertical height, but don't forget to write it negative. Solve this equation, you will get frictional force, then it's easy to get the coefficient of friction.